Righty. We're live for Advent of Code 2025. Um, this year's a little bit different. We only have 12 days of puzzles, and the first one drops in about an hour. So, given that we have a shortage this year, I think this is the perfect time to go back through past years. So, I started doing this in 2021, and I've gone back through some of the previous years. But I think what I'll do is 2015 in parallel to 2025. Um, so I'll start off with a few 2015 problems, and we can hit the 2025 problem when it drops at midnight. Um, yeah, there's also no more global leaderboard. So I suppose this year is a bit less intense, less hectic. A good year for taking it slow and steady. So, day one, 2015, the first ever Advent of Code puzzle. Not quite Lisp. All right. So here's our usual Advent of Code explanation. We need 25 stars and an easy one to warm us up. Okay, we're delivering presents. The directions are confusing. Starts on the ground floor and follows instructions. Instructions, open paren, go up one, close paren, go down. Okay. The basement is very deep, the building's tall, so infinite floors. Great. So they don't even need to be balanced. Um, which is to say you can go into the basement. Great. So this is pretty straightforward. Basically, ups minus downs. So input.count. We need to count the open parens. Oh, and you know what? I think I want to turn off Copilot. Copilot. Disable toggle. And yeah. Okay. We don't need Copilot here. It's just going to solve the problem in front of us. Okay, so we're going to count open and subtract closed. And that should be our first answer, 74. All right, part two. Um, find the position of the first character that caused them to enter the basement. Okay. We could just do a fold. This is a scan actually. We can do a scan on the input. So scan is kind of like making a prefix list. It's like you're folding left, but you keep the intermediary value. So we start at floor 0. And then we have incoming characters, and then we have a current level. So we'll say L for the level and C for the character. Excuse me. Let's just match on the character directly. So if it's open, then we go to L plus 1. And then if it's closed, we'll go to L minus 1. And we want the position of the character. So val positions, that's all the positions. And just to verify, if you can see it goes up and then back down. If we look at our input, let's take a look at our input. We can verify that there. So the first few steps are all up, and then there is a down step. 1, 2, 3, 4, 5, 4. Yep, that looks about right. So we want positions index where it goes negative. Index where we'll just say less than 0. I assume 0 indexed. The first character is has position 1. Okay, so this should start at 0 with the 0 index. So ends to 1795. Okay, pretty straightforward. Let's go to day 2. Okay, so I'm at this rate. Probably I might finish 2015 before I finish 2025, in which case I just go on up to 2016. I'm still trying to decide what to do for days 13 through 25 this year. I will stream every day. I just need to figure out something that's not Avanico 2025. I mean, maybe I'll redo it in Unison. Unison language just hit 1.0 this last month, and I've been meaning to try it out for a while. So I'd like to see how Admod code looks in there. Um, of course, I could always go back through past years and try to finish that. And Cinecore, another project by Eric Wastel. Maybe I'll do that. We'll see. We can talk about it throughout the month. Anyway, we have day 2. Um, let's start a new worksheet for that. And what do we have here? Okay, we're wrapping presents. We have dimensions linked with height. Find the surface area of the box, and then a little extra paper, the area of the smallest side. Okay, so 2, 3, 4. Surface area straightforward. 6 feet of slack because 2 times 3. Okay, we'll turn our input into a list. And excuse me. So we can just match in our input. So input dot map case, and then we can parse that string. So length. Oh, but so we have length by width by height. And those need to be integers, I suppose. So about surface area. Actually, you know what? Let's do it this way. Let's parse the strings. See, this is the place where you do want Copilot. We'll just have Copilot complete that. Okay. And then we have Slack. I'll just name it out. Surface area and Slack is what? How is it guessing that? Anyway, we'll do like list length width height that's sorted. How does it know? It must be like trained on that in the code and know what problem I'm trying to solve. I mean, that's exactly what I'm gonna type. No, that's not what I wanted actually. Take two, and then we just take the product. Okay, yeah, take the two smallest dimensions, take the product. So surface area plus slack. Oh, I hate this autocomplete. I'm disabling that. There we go. And this is answer one. Well, not quite. Let's just call this the um, paper areas. Okay. And it's just the sum of all of those. 3912972. Oh, too high. Well, the first answer is 2016, so oh, it's not 2016 this year though, so that wasn't a hint. Anyway, surface area. Uh, length times width times height. Oh, fuck. This is the volume, not the area. Okay. Length times width time plus width times height plus length times height. That's the area. And it's times two for each of those. Okay. I'll give it a sec to update. One 598.415. There we go. Part two. Ribbon is all the same width, so they only have to worry about the length. Ribbon required to wrap presents is the shortest distance around its sides or the smallest perimeter of any one case. Um, yeah, before we do that, let's just do a quick refactor here. We'll call this dimensions when we parse these. So val dimensions is this part. And we're just going to do a triple L.to int, W.to int, and H.to int. Then when we do this, oh, hey, I am not doing 2025. This is 2015. So so I haven't done all the past years. So I've decided that for this year, I'm gonna back solve previous years as a warm up. But also, I don't know. Admin code's only 12 days this year, so maybe for the rest of the 13 days, I will just solve the past year and try to finish that by then. Anyway, I still have, you can have a total of 500 stars, so I still have like 220 to get. Okay, let's change this match case. Length, width, height, surface area, and slack. Okay, so part two is a ribbon length. You only have to worry about the exact, about the length we need to order, which again might have to be exact. Okay, The shortest distance around its sides, or the smallest perimeter of any one face. Okay. Uh, each present also requires a bow made out of the ribbon as well. The feet of ribbon required for the perfect bow is equal to the cubic feet of volume of the present. Okay. Wait, that's weird. What? That's huge, actually. Let's say you have a 2 by 2 by 2 box. You need 8 feet to tie the bow. They must have some weird way to do it. All right. So we'll take our dimensions, map, and then K. So we have our length, our width, our height. And we want the smallest perimeter. So val perimeters, let's take them in. Ice Cold Witch, hey, how's it going? Welcome, welcome. Having code is finally here. Oh wait, that's not perimeters. Perimeters is the sum of those times 2. So we'll just take the sums of all of these. And then we have length plus height, dot map times 2, and then dot min. In fact, what we could just do like min times 2. So that's the smallest perimeter. And then to that, we will add the volume, length times width times height. So val ribbon lengths. And then answer 2 is just the sum of that. Okay. We have something going on here. Oh, we're not mapping on input here, we're mapping on dimensions. Uh, I wonder how many I can get through before day 1 drops. I could probably get 5. I don't know why this isn't loading. Another year of AOC. Yes, indeed. Sparkly Dark Matter, welcome. Dev Cheetah, welcome. Another year. In a way, last year kind of felt like a last year because it was celebrating the 10th anniversary. And it's also the last year where there's a global leaderboard, last year where there's 25 problems. So this feels like the bonus extras for all us addicts. I still have to go back. I still have all these stars to collect. Um, ribbon links 3812909. 3812909. Yeah, the encore, exactly. Okay, day 3 of 2015. Perfectly spherical houses in a vacuum. Okay, two-dimensional grid of houses, grid problem. An elf is telling him where to move. Too much eggnog, so his directions are a little off. Santa ends up visiting some houses more than once. How many houses receive at least one present? Okay. So basically every point visited by following this string. Let's take a look at the input. Is this just one line? I think so. Hmm. Okay. So let's get day 3. Since this is just one line, we'll change this to next. And I have like a point library I might be able to use here. I think what I want to do is a scan left, so I get every position that Santa visits in order. So we'll do input dot scan left, and I want to use my point class, so AOC dot point. So we'll start at the origin. Hmm. And we have our position, and we have some character. I think we will just parse the character directly here. So there could be up. So point moves up. Point dot north or p dot north, p dot n. Okay. And I'm going to turn on autocomplete for this case. All right. So this is the path. And what do we do with the path? We just want to know how many houses? How many houses are visited? Okay, so path dot distinct dot count, or dot size. 2081. Cool. Part 2. The next year, Santa creates a robot version of himself called Robo Santa. Santa and Robo Santa start in the same location, then take turns moving based on instructions from the the eggnog elf. Okay. Delivering two presents to delivering two presents to the same starting house. Oh, okay. So they both deliver. Then they take turns moving. Ah, I see. Okay. So Val Santa path. So it starts at the origin. So input. Um, not all the input though, just every other. So who goes first? Santa goes north, and then Robo Santa goes south. 30 minutes. 30 minutes indeed. Very close to time. Okay, so Santa path. We just want every other from the input. So what do we do? We do like a sliding size 1 and a step of 2, and then flatten that. Okay, so we've got Santa path, and we just do this kind of same thing um, as here. We can make this a function. We have a point and C direction. I'm just going to copy this code from before. Hmm. Um, PC match. Okay. Okay, now our sent path, we flatten, and then we do the same thing as before, which is scan left from the origin with the move function. And then we do the same thing, a similar thing for Robo Santa. So we'll do input dot tail, that sliding flatten. And then we still want to know how many receive at least one present. Okay, so Santa path To set plus robopath. Rare Scala developer. The species is almost extinct. There are dozens of us, I tell you. They've been almost extinct since the start. Hmm. So we're just gonna union these two sets. Union robopath dot to set, and then just decides that. No, this is not a direction, this is a character. Honestly, this case is often is common enough. I should just put that in the library. To do add pair movement to the library. 2341. All right. Scan left is a nice tool. I like it. I like using it. Day 4. Let me put an alarm. So we'll do like a 28-minute alarm. I thought Google had a there we go. I'll go off. There's 3 minutes left. Okay, day 4, 2015. Um, Santa needs help mining Advent coins. Economically forward-thinking little girls and boys. Yeah, 2015 would have been before the big Bitcoin boom. We need to find MD5 hashes. The input to the MD5 hash is some secret key or puzzle input given below, followed by a number in decimal. Okay. You must find Santa the lowest positive number that produces such a hash. Oh, okay, so we need to find a number that produces a hash with 5 zeros. Is that what it's saying? So if your secret key is ABCDEF, the answer is 609043 because the hash of that starts with 5 zeros. And it is the lowest number for such number to do so. Okay, there's nothing to do but like brute force this, right? I mean, that's kind of like the point of Bitcoin. So this is our proof of work. Okay, let's take a look at the input. Oh, the puzzle input is just that. The secret key. All right. MD5 hash. That should be in the standard library somewhere. Let's see. I'm gonna turn on Copilot here to ask. Using standard library. Okay. There we are. Now we can turn off Copilot. Just a message that hope that's right. I'm not familiar with message digest. Let's try. Let's just try on something. So MD5 hash of Stewart, and in the meantime, let's just compare it against like Linux. Okay, MD5 sum of Stewart of echo Stewart. Oops. Okay, that's what we should get. AE463. We're getting different answers. Okay, so that's not the thing. But we can still write the rest of the algorithm and then figure out how to get the proper MD5 hash later. Um, let's to the MD5 hash is some secret key followed by a number in decimal. Okay, so we'll do like iterator dot from 0. Wait, does it need to be a positive? Lowest positive number. So we'll iterate from 1. So we'll do input plus our number as a string. And then take the MD5 hash of that. And our answer is the first one. Oh, we do like a collect first here. Collect first n such that taking the first 5 digits, take 5. 0, 0, 0, 0, 0. Right. Iterator dot get. Okay. I don't want to save this yet because if it's an infinite loop, then we're we're in trouble. Let's make sure MD5 works properly first. So we could try, for example, MD5 of one of these. This secret key, A, B, C, D, E, F. Plus, what's the number? 609043. Okay, so that should start with 5 zeros if MD5 is working correctly. And in the meantime, let's look up Java MD5 function. Yeah, instance string algorithm. Okay, yeah. I don't know what this digest is. So what does this like digest the bytes? Okay, yeah. And what does it return? A byte array. So that byte array needs to be turned into a string. Oh, wait, this is fine. This is correct. Okay, there might be a slight difference when you're doing the checksum of a full file. Okay, so our MD5 is correct. Let's just get our answer then. Not iterator.get. This is the, what do we call this? We'll just call this answer. Well, ans1 was that, and then .get. Suppose we could just do a find here. I'm having a weird issue here. It evaluated in under a second, but my thing is not showing up right away. Wait, why is .get false? Option of Boolean? Oh, wait. We want to find the first n such that that is equal to 0. Okay. Okay, it took 7 seconds to load that, but the answer is, can I see it? 254575. 254575. Okay. Part 2. Find one that starts with 6 zeros. And we're supposed to just let it run. There's no faster way to do this, right? Because the point is it's difficult to reverse a hash. Okay, fine. Oh, hold on. Cancel that. Cancel that run. That's never gonna complete. It takes 6. I suppose I could make this faster by not making that make string. Yeah, let's not create an unnecessary string. We'll just say take 5. That for all, and it's the 0 character, right? I see Black Deep. You forgot about AOC? You can't do that. Well, there are some surprises this year. It's only 12 problems, and there's no global leaderboard. But good to see you again. It's been a whole year, hasn't it? Fair enough. I was gonna stream more this year, and then chaos struck this year. Had a cat get cancer in January last year. So that kind of threw a wrench in things, and spent the next few months taking care of the cat until she died. But maybe this year will be different. There's only 12 days of admin code. So for the rest of the month, I have to figure out something else to do. And I have a couple ideas, but that means I'll have to do something that's not just given to me here every day. Yeah, it was really sad. Thanks, I appreciate it. Um, hmm, is this evaluating? Mhm. Thanks, Ice Cold Witch. Okay, is this still running? No, it finished in 30 seconds. I'm just not seeing my answer. These answers are slow to load for some reason in the worksheets. That's something I'm gonna have to debug. Apparently it's okay, now it's reevaluating again. Oh, it timed out after 30 seconds. That's what happened. Um, okay. Well, there should be a way to do this faster, right? I'm not just gonna let it run. I could increase the timeout, but that feels wrong. Are MD5 hashes actually like reversible? No, that's against the whole point of the hash. Yeah, it's mathematically impossible to reverse an MD5 function. Yeah, of course. Uh, there's nothing to do but brute force this, is there? Yeah, yeah, right. Okay, well, I don't want to brute force it for longer than 30. You know what? I'm just gonna increase my timeout. I think I need to ask how we go about this. I'm using metals, VS Code, metals worksheets. Um, all right. Let's put this in the settings.json. Okay. Um, metals.server properties. Oh, why is it auto-completing all that? Do I have it somewhere else already? I don't think I need all of that. I just need the timeout. Okay, let's see if 60 seconds is enough. Okay, just restarting the server here. So I don't know. What are all of you planning to do for day 13 through 25? Are you gonna do more admin code related stuff, or just get on with your lives and stop ignoring it? Sleep, all that kind of stuff. I was kind of looking forward to being sleep deprived all month. I'm not gonna lie. Having an excuse to avoid family and friends. You'd like to say you'll sleep, but you know you won't. Fair enough. Intro class. This year you're using your own compiled language, so you'll have a long backlog of issues to address. Oh, cool. Yeah, that sounds like a good side project. Yeah, you'll discover those issues as you're using it this year. That's cool. What's your language like? If you have a link, I'll check it out. Timeout reached. What was the timeout? Oh, wait, wait, wait. No, it did not hit the timeout. Family doesn't need to know the puzzle stop. That's true. Sorry, I'm doing that in a code. Let me just fiddle with a setting here real quick. Alex, you're gonna prepare for January layoffs. Are January layoffs a thing? I feel like there's usually a January hiring spree because there's no hiring in like November and December. Hmm. We have time to sneak in one more. I might just move on to day 5. I don't want to waste time brute forcing this. Kind of see-ish with some bare bones struct and pointer types. Okay. I've written a compiler once. If you're familiar with NAND to Tetris, that project, I had a lot of fun doing that. So, kind of a small Java-like language. You brute force in Java, it took less than 1 second for part 2. Really? Really? Um, okay, I mean, I suppose I should just make this more efficient. I guess 5 zeros isn't like zeroing out the whole thing, right? Um, I mean, I could turn this into like while loops and whatever to like micro optimize, but I feel like there's something. What I do? MD5 input plus n.toString. Um, there's no reason that should be an issue. I mean, okay, the digest returns the bytes. I could just look at the first 5 bytes of the array and check that they're all 0. Um, oh wait, it's taking 2 at a time? Um, I suppose. Yeah. So I could take that out. I could turn this into a while loop. That'd make things tighter. Okay, I'll revisit that in a minute. But for now, I feel kind of done with this problem. Let's see if we can finish day 5 real quick. Okay, Santa needs help figuring out which strings in his text file are naughty or nice. A nice string is one with all of the following properties. It contains at least 3 vowels, contains at least one letter that appears twice in a row, um, and all these need to be true. It does not contain any of these strings. Okay, so that's source, resource, and what is this, 2015 day? Just copy paste this. Okay, so we'll get all those lines. And we need a nice function, def nice. And it has 3 vowels. So this is what a Boolean. So vowel 3 vowels equals s dot count. Let's see. We'll just make a vowel set. A O E A E I O U to set. Is greater than or equal to 3. Okay. One letter that appears twice in a row. Vowel duplicate. So s dot sliding 2 contains, and what's this going to, an iterator strings. So a string such that s dot head equals s dot not last. um, okay. Well, not blacklisted. So we have like our blacklisted diphthongs. Well, they're not really diphthongs, but I'm gonna call them that anyway. Or we'll call them bad strings. A, B, C, D, P, Q, S, Y. No bad strings. Okay, so hey, good morning, Blue. Welcome, welcome. Yeah, it's really been a year. Okay, it is almost time for the problem. Oh, my timer went off and I didn't hear it. It was muted. All right, just in time. I'm gonna comment this out and set up my day 1 for 2025. I'm there. Ah, alrighty. Are you all ready? Who else has said there's only 12 days this year? I'm gonna sharpen the skills again. Yeah, after not doing this for a whole year. This is the only kind of thing like this I do. I mean, I've done a bunch of Project Euler. I've done some leak code, but I don't really like it. I imagine if I just did leak code all year, I'd be faster at this. It doesn't quite have the same charm that admin code does. I've heard that it rises faster. Maybe the middle won't be as high as the normal middle. He still wants to keep people on as long as he can. Um, but yeah, other than that, like 12 will be as hard as or like, yeah, 12 should be as hard as a 24, day 24 problem. All right. See you on the other side. I see Black Deep. Good luck, everyone. It's nice to be back. Good luck, Ice Cold Witch. All righty. Elves have good news and bad news. The good news is that they've discovered project management. Uh-oh. That sounds like bad news. This has given them the tools they need to prevent their usual Christmas emergency. Blah blah blah. I'm gonna skip ahead to understanding the problem. You need to finish decorating the North Pole by December 12th. Okay, we need stars. You arrive at the secret entrance to the North Pole base, ready to start decorating. The password seems to have changed, so you can't get in. Okay, we need to get the password. The safe has a dial with only an arrow on it. Around the dial are numbers 0 through 99. As you turn it out, it makes a small click as it reaches each number. The attached document, your puzzle input, contains a sequence of rotations. Okay. L or R. Let's just see the input. Oh, okay, so we follow the dial. Let's, because the dial points to at 0 a total of 3 times during this process, the password in this example is 3. Oh, the number of times we hit is 3. Okay. So this is just another scan left. We literally just did this. So input dot scan left. So we start at 50. Um, and then we have our position. So position and then a string. So it's either L and then some number. Wait. So L and then some number. Um, let's call it N. So then we subtract 50 minus and dot to int, and then we're just gonna mod that whole thing by 100. I assume there are 100 positions. 0 to 99. Okay, yeah. Mod 100. And then we'll do the same thing for the right. And it's not 50, it's the current position, so pause. Pause. Plus mod 100. And val ans 1 equals positions. We're just gonna count the zeros. Dot positions dot count equals 0. Puzzle inputs differ by user. Please log in to get. Wait, what? Log in? What happened here? Log in to get your puzzle input. I'm not logged in. Source. I don't want to show my session key. Um, okay. Okay, I've got my inputs now. Nope. Wait. I just fixed it though. Come on. Okay, it evaluated it. I'm just waiting for it to show me my answer. I want my answer. Oh, it's gonna be a little bit annoying. It's not showing when I update things. Okay, 1195. Okay, there we go. Part two. You're sure that's the right password, but the door won't open. Please use password method, yada yada. Remember from the training seminar that method means you're actually supposed to count the number of times any click causes the door to point at 0, regardless of whether it happens during a rotation or at the end of one. Okay. Okay, so we still. So anytime we pass it. Uh-huh. So is there a limit to these? I assume you never turn more than like 99, right? So we can just do. We can keep our positions and just count something else, like a sliding list of 2. No, that won't work. Um, so we do still need like the state, the sliding state. Um, so every time we do this mod 100, that's adding to our count. Um, we could do the sliding list of 2. Now we don't want to do that because we don't know which direction it was turned, so we don't know if it passed over the 0 or not. Um, so I think we just need more state in here. So we'll do a count. So we have a position and then we have a count. Position and count. So we get the new position and then the new count. So let's see. And basically, if it is over 100 or under 100, So if 0, wait, let's say if 1, 299, if 1, 299 contains next, then we just increment the position, we keep the count the same. So next and the same count. Otherwise, we do increment the count. So positions, we're going to split that at the end. Okay, so otherwise, we still have next. We have next mod 100, and then we have count +1. All right, and we basically have exactly the same thing here, but a plus, and we can clean this up later. Definitely don't need to be keeping all of this data anymore. Um, so at the end of all that, we're going to do a unzip dot unzip. So we've got positions and we've got counts. And val ans2 equals counts dot last. 3463. 3463 is wrong. Okay, well, we can inspect our data. So let's take a look at counts. Positions is still accurate, right? Cool. We can zip those two together and see how that changes. And maybe I have an off by 1. No, it starts at 50. And let me make sure I'm understanding this. Any click causes the dial to point at 0, whether it happens during a rotation or at the end of one. Right. Okay, I think I'm understanding it correctly, right? You went left 68, you passed over the 0, and that counts. So anytime you're not in this 1 to 99. I mean, just to test our logic. Well, let's zip these together and take a look. So positions.zip counts. And let's just do it for each print line. Inspect that. Okay. So 50, that's 0. Oh, I should also zip this along with the instructions. I mean, I should just take a different approach to this second part altogether. Because we don't even really care as much about all of the positions along the way. We just want the sum at the end. So it no longer needs to be a scan left. Oh, hey, we have a negative 20 position. We're not supposed to get to negative 20. Oh, hold up 1 second. I think we are misusing the mod. Okay, let's say 50 minus 68. It's gonna be negative 18, and then mod 100 is not gonna be. Yeah, that's not right. Oh, it's still negative 18. I see. Oh, so it doesn't happen until we go over 200. So that's why we're miscounting. So let's say minus 168. I see. Okay, so we need to normalize it and make it uh, make sure it stays positive. So we're just gonna add 100 before we do anything. So next, pos plus 100 minus n.2int, pos plus 100 plus n.2int. Okay, that should fix everything as long as it compiles. Oh yeah, that's not exhaustive, but we don't care. 3753. Oh no, that's still not right. Okay, I mean, we did find a legitimate issue though. Oh wait, here. We fixed it in the wrong way. Uh, So we should leave that plus 100 out of that. We just do a plus 100 when we're doing the mod calculation. So we do next plus 100, mod 100. Okay. $33.10. No. Okay, so that should normalize it, yeah? Right, so let's say we went left 68. Um, but we added 100 first. Then we get 82. Right? And let's say we went right by 68. We get 18. That makes sense. Okay, so that's not the issue. We we normalize that correctly. Next plus 100, mod 100. Um, and if it's still in the same positive range, you don't worry about it. Once you've hit 100 or 0, which means it's outside this range, right? So 1299 contains, it's going to contain 99. Okay, once we're outside that range, we do this. And we add to the count because we've hit either 100 or 0, or like passed over it. Okay, 50, 0, 49. Let's look at our input and let's just compare until we see an issue. Oh, wait. Here we go. So let's look here. So we go left one to get 49, 0, right. Then we go right 43, right 6, and then right 50 gets us 1. Cool, that looks right. And then right 47 gets us to 95. Right 18 gets us to 13. And then count increments to 2. So that seems correct. 1, 2, 3. Okay. We have like an off by 1. No, we just get the final count. When we hit 0, it went up to 25. Um, and we end with 3310. Just try 3310. If the dial were pointing at 50 in a single rotation like R1000 causes the dial to point 10 times. R1000? Wait, can they be that big? Oh my god. Okay, we can have many times more. Okay. Did you just finish? I just figured out what my bug was. I assumed um this right here. I assumed that there was a limit. You can only rotate like 99 at a time, but you can rotate a lot more. So count um is never just +1. It's just hmm, what's it gonna be? Like the number of times 100 fits? So if you went all the way to 150 or something, then that's 1. And that would be 100. That'd be next divided by 100. So at least in the right-hand version, 100 divided by next. Or rather, next divided by 100. Next divided by 100. Cool. And then now in the negative version, it's still going to be next divided by 100. But there could be an off by 1 kind of thing going on here. So let's say we're negative 50. This is going to undercount by 1. So we just add 1. Alrighty, we've got it. We've got it. Eric, Eric Wassel, welcome. Good to see you. It's been a year. This might be the year I do Cinecore because there's only 12 days. I might spend day 13 through 25 doing that. 18 minutes. Oh my God, it's 22 minutes. This is a day one problem. Okay, but we got it. Oh no, we didn't get it. Uh, okay, I should do this with example data. Well, the example data doesn't have like 1000s in there. I can make my own example data. Oh yeah. Yeah, definitely you should tell people about it. Maybe we can all do Cinecore on day 13. That'd be fun. I'll spread the word. Oh, I'm doing all right. I meant to stream more of like something else this year, but I haven't streamed since last Sabbath in the Code. This year's been chaotic. Glad the puzzle unlock went smoothly. Um, oh, I'm doing here. Um, so I thought this was my issue here was that I wasn't counting the number of times. Let me just pull out my scratch pad here. So let's say we have I don't know, 50 plus 50 plus 68, right? Um, we had 168. Okay, so that's one click, that's two clicks on the zero. And let's say we have minus 68. Oops, 50 minus 68. Divide by 100. That's going to be 0. How about we do the plus 1? Oh, wait, we need the absolute value. Yeah, because we'll just do 168. Yep, okay, there it is. Um, dot abs plus 1. Or, we could like divide by negative 100, I guess. Either way, that should get me the answer. 7386. That sounds more like it. 7386. What? I have a timer? No. All right. Well, let's recap. What were my issues here? Um, okay, so when I transitioned to part 2 here, I introduced this branch. But uh, I was doing the mod 100 and then not normalizing for like um for negative numbers, right? Because negative 30 mod 100 is just gonna be negative 30. So at first I put the mod 100 like up here when I'm calculating my next position. Um, but then that caused issues because I was using that next position to decide other things here. So I moved it down here. Um, and then what was the next issue that came up? Oh, I didn't realize you could go around more than 99. So you could go around multiple times in one spin. Um, and then I had to fix the negative. Okay. 33 seconds left to wait. Yeah. Um, I don't know why I didn't want to think about it. Like it was in the back of my mind. I was like, modding negative numbers. I just want to think about how to, you know. I was feeling lazy. I was like, just make it work. Let me just write it and have it work. Plus 100. That's one fix. I know. I know. In the Java standard library, there is a different mod function that operates differently with negative numbers. Someone was discussing it in the past. I have in the code. That included part 2, and an example that included the tricky bit for me. Yes, the big clue that says "be careful." This is how I found the issue is reading. Oh, there's a "be careful" here. Okay, reading comprehension. It should be enough time. Wait, 7386 is still not it. It might be time for a rewrite. Okay. So we get our next position. If it's within the normal range, then nothing happens. We just have our next position. Um, Otherwise, we do this normalizing for the mod 100, and then the count. Am I still not doing that count right? So we're going to do the absolute value of this. Right, 50 minus 168 should click twice, right? If you go minus 268, that should click 3 times. Cool. And if it's just minus 68, it clicks once. Okay, yeah. And, if it's less than 50, then it's not even going to go into this branch. Okay, so that seems correct. California and India, welcome. Oh, yeah. Eric Wassel, hi, bye. Good to see you. Thanks for stopping by. You just did I++ or I minus minus and simulated the entire thing. That's kind of what I'm doing here, right? So scan left keeps track of everything. So I have the full list of all the positions and then the count at that position. So I have simulated the whole thing. The simulation looks correct. Wait, there's a negative in here? Ooh, there's a negative. That's not good. Okay. Well, let's make sure there's no negatives. Um, plus 100 mod 1000. Oh, wait. Plus 100 is not enough to normalize it. Let's just do plus 1000. There's nothing greater than 1000, right? Heck, let's make it 10,000. There, it is normalized. 7363. That's lower. Lower sounds right. And I'm pretty sure I can't submit. 2 minutes. Okay, well, we can wait 2 minutes. Man, I'm an idiot. Um, Jeez. Well, let's clean this up. Let's clean this up while we're doing this. So I think this whole bit can be a function. Um, yeah, let's just call it like we'll just call it normalize. So there's a position, and we can just do this whole bit. Um, and we could probably take out these 2 branches somehow. We could put the branch. Let's do this. So val delta. So we have some n here, right? And match. So we have so L delta, and then we do d dot to int minus d dot to int. And we'll do the same thing for the right. And we can probably submit by now. 7363. Oh no, that's still not right. Okay, well, I guess we could do our rewrite while waiting. Um, okay. Next plus delta. I suppose it does matter if it's positive or negative for this part for determining the count. Count plus next over 100. And if it's negative, you add an extra 1. Okay. Mm-hmm. Let me just check my inputs real quickly. Maybe there's one. It doesn't seem like there's more than a 3-digit one. I mean, I can verify that in code, I suppose. All right. I should scrap this rewrite. All right, next is pos plus delta. Then it's just next and count. Well, we still have a different different count here, so clicks. Val clicks. So if it's less than 100, if next is less than 100, or less than 0, I suppose. Next, divide by negative 100 plus 1. Also, next is greater than or equal to 100, then next over 100. That's 0. Okay, that's a bit more explicit. So normalize position, and then we do count plus clicks. All right. If everything's fine, we should still get the same answer for part 1. And we're not currently getting the same answer for part 1, so we changed something in here. Next is plus delta. Oh wait, this code is still here. Normalizing position should be fine regardless, right? Okay, so we can just delete this bit. All right. So wait, next divide by negative 100 plus 1 if we're moving left. 6726. That might be it. 6726. We still have 28 seconds to left. Wait, okay. I don't know what changed when I rewrote this, but the answer changed. So that must be it, right? We'll try again in a few seconds. And let's submit it. No, no. I'm so rusty. Um, okay, let's test each of our little bits here. So are we counting the clicks properly? Are we still getting the right answer for answer one? Yeah, so our position is still updating fine because we're still finding our zero positions. Um, but now are these counts correct? This is the same thing we're using up here, right? So 50 minus, let's just try this with a negative. So we divide by negative 100. Yeah, minus 68 should be one click. 168 should be two clicks over the zero, right? And plus 68 should just be over 100, no plus one. Yeah, this is our algorithm. Our clicks are fine. Wait, let's check on this. Do we still have any negative positions somehow? Let's make an assertion. So positions dot for all greater than equal to 0. Or what we could do is say 0299 dot contains that position. Okay, cool. So we have our check. All of our positions are within 0 to 99. Um, oh, this is suspicious here that it never increases. Do we really have a string that long that never? Okay, well, let's zip that yet again with the input. I want to see what's going on. I mean, it's suspicious that it stayed at 4 for so long. So starting here, right 15, right 1, left 19, right 36, left 33, and right 25. It seems fine. Right 16, left 43, right 27. When's the find the increase? When we're at 55 and you go right 49, then we end up with 5. We just tried 7363, right? I need to look at my it's day one. I need to look at my am I being stupid list. So works on an example. I guess we could try an example of some sort. Copy paste correctly, no unhandled to-dos. Temporary shortcuts. There are no temporary shortcuts. Um Regressing too far, off by 1. I don't think this is an off by 1 kind of situation. I mean, let's look at the last position here. Let's do dot take right 10. Did I sleep and did I get coffee? Um, I did sleep. Okay, the final position is at 59, 7363, and then we go left 5. Wait, there should be another position after that. If there's still. Did I consume my entire input? Let me look at this real quick. Input dot length. I mean, that's still the right answer for 1, right? That's still the good right final position. So it can't be. Or the right number of zeros, rather. So input.length, decisions.length. It should be input.length plus 1. Right, so this just wouldn't be showing that very last position. Um, and we could do one of these examples here. All right, let's construct an example. Day 01.text 2025. Day 01 example. Okay. All right, let's try it on the example and see what kind of result we get. The dial points at 0 3 times at the end of rotation, plus 3 more times during a rotation. So we should get ANS1 is 3, and ANS2. Oh, we're wrong even on the example. Okay, I guess we should try the example sooner. Left 68, it points at 0 once. Okay. Left 30. Oh, wait, to point at 52. Okay. Right 48 to point at 0, and that bumps it up to 2. Okay. And then left 5 to point at 95. Okay, that's good so far. And then we go right 60 to point at 55. It passes once. 55 passes once, 4. Great. Rotate left 55 to point at 0, left 55 to point at 0, and that increments us. And then left 1 to point at 99. Oh, there it is. When I go from 0 to 99, I counted it. When it's already at 0, I see. Anytime it's already at 0, I'm counting that as extra. Ah. Okay, we just subtract times 1. Or, well, there it is. Okay, Blue. Thanks for stopping by. Good to see you. Yep, I see Black Deep. You saw it. You saw it. Okay, so if it's already at 0, we don't count anything. Or like we subtract 1 from the count. So I'm overcounting when it's negative. If I go right from a 0, where 0... Okay, if I go right from 0, right 14, I don't count that. Right, I'm looking at... Okay, if next is less than or equal to 0, this is a problem here. I think it's just if it's less than 0. Well, no. Well, I mean, that should be less than 0 for 1. Yeah, that is it. That is it right there. Okay. Not less than or equal to 0. 6905, we finally got it. Oh boy. No, it's still there. Okay, we know what the kind of issue looks like though. There's probably still an issue here. Um, if we're at 0, um, okay, let's say position starts at 0 right now, and we have negative. Yeah, fully avoiding negatives is probably a really good idea. You said you didn't want to worry, so you started at a big number plus 50. Yes, yeah, good way to do it. Okay. Hmm. Yeah, or like you might it work if you just do like plus 100 and normalize to that? Well, anyway, um, let's say we're starting at 0. If next is less than 0, then let's say we move left 5. Then it's gonna think we clicked, even though we were already at 0. But that's only gonna happen in the negative case, I suppose, not in the positive case. Right, because we're doing this plus 1. Uh, less than 0 when... It's not just that next is less than 0, because it has to pass over 0. So if position was positive, I guess, that feels hacky. I want to have like a simpler expression here. This bit here, I suppose I could rethink. Would we have the same problem with 100 actually? Not necessarily, because if we had 100, we'd be at 0. Um, I suppose if position is 0, we could just add 100 here and subtract 1. Yeah, let's let's just get this out of the way. Um, I don't have a nested if branch in here though. Oh, okay. If just do another if branch here. Pos 0 and next is less than 0. Then next divide by negative 100. I'm sure there's a nicer closed form. 6312. I still have to wait 5 minutes. Mm. Oh man, that scales aggressively. Man, that's been hurting me. I spent a lot of time just kind of sitting and waiting for I guess Eric's encouraging us to check our answers, which I can do with example here. Okay, yeah, I broke it. This line's not good. I know, that's a brutal layoff on those times. But it's not correct anyway. This isn't good enough here. So if position is 0 and next is less than 0, then we just do next divided by negative 100. What happens with that? So let's say 0 minus 68 divided by negative 100. Yeah, great. But if we did minus 168, then that'd be 1. That's what we want. Um, right? Okay, so this one works for the example, and it just works accidentally because I suppose we never run into. Okay, left 68, we hit it once to 52. 48 gets us to 0, so we hit it again. Then left 5. Oh, I'm still incrementing here. Okay. Um, right. If next is less than or equal to 0, that means it's hit 0, assuming that we didn't start at 0. Right. Less than or equal to there. Otherwise, if pos is equal to 0 and x is less than 0. Okay, that should fix it. So that should still work here. Cool. Special case. So it was kind of in a way an off by 1. I need to find a better way to express this. I don't like having bugs like that. It's really hard to debug. 6770. But we still have to wait a minute and 40. Eric. So Icy Black Deep, you did yours. Did you do it by adding a big 100 or like a big number to it? Or you were just really careful with your mods? I think I really wanted to have a nice tight closed forum, and I just didn't want to write things out explicitly, and that just made things harder. I was like, ah, day one problem, it should be short. Yeah, yeah, I'd be happy to have a look. 25 seconds. Let me finish first, though. Um, I really hate having these special cases. Mm. You did it without mods and repeatedly plus or minus 100 with a special check for starting it. Oh, I see. Right. So you just count the plus and minus 100s as you're going around. Yeah. I mean, that's definitely foolproof. Yeah, I hate having to do that though. I hate having to check that we're starting um a left turn at 0. I just want to have a nicer expression. Like it's nice. It's somewhat symmetric, so it's nice when you have an expression that works whether you're turning it right or left. I just can't think of it right now. But I'm sure there's like some clever way. I'm sure someone's been able to think about that. Let me submit. There it is. There it is. Okay. Jeez. That was a rough day one. Check the leaderboard. Um, this is my leaderboard, right? Why am I only silver right now? Didn't I just get a star? Um, what did I do for part one? Sixth for part one. That's not bad. Horrible delta time though. I took part one pretty relaxed. I think I could have written the same thing faster. Oh, the leaderboard? Yeah, here. Bang leaderboard. No, no, no. AOC. There we go. Good. I'm glad day one wasn't just a speed typing contest? Hmm. That's what it feels like on some of the past years. Just how fast can you type the one liner? Part one was a one-liner, sort of. Let's just clean this up a little bit. Um, I'm happy enough with this code. I wish there was a nicer closed form here, but we don't need to be clever. Being being not clever makes for code that you can be sure works. This special case, though, that was hard to predict needing that. All right, let's take a look. So this is your code, Icy Cold Witch. Ice Cold Witch. Ice and Icy in the chat. Mod 100. Okay, Python. Okay, if it's left, you add, or otherwise you subtract. And then every time it's a zero, you add one to the answer. Great. But this part two, or current is greater than previous and previous is not equals zero, and plus equals one. Okay. The R case is so much nicer. You think on the left it should be subtraction? Oh, yes, yeah. Subtracting when you're turning left. Oh, thank you for the follow. Okay, here is Icy Black Deep. C++. Can I make this bigger? Oh, I don't think I can make it bigger in here. Hold up, let me pull this in a proper browser. Okay. If left while my position is less than zero, plus or minus one, wait, plus 100. All right, otherwise position equals one, doesn't matter, just not zero. Okay. And then you update the new position. Okay, so zeros for part one. Oh wait, no, this is part two. Okay, well, we're greater than 99, we keep subtracting and then add to zeros. Makes sense. Wait, where's the left case though? It's because he added 100? No, if left. No, this is the right case. Right. So you keep subtracting in the right case and in the left case. Ah, I see. I see. While it's less than 0, you keep adding 100. And if it's not 0, you do the zeros plus plus. Okay. Cool. Well, thanks for sharing. Ah. Well, I think I need to redeem myself real quick. Um, Let me finish off at day 5 from 2015. This one seemed pretty simple. So we're looking for nice strings. Deep mistrust of modding with negative numbers. I don't blame you. I don't blame you. It really got me there. Zuno, I'm just gonna call you Zuno for now. Oh, on the AOC sub on subreddit. Hi, how are you doing? Thanks for stopping by. Oh, you mean the streamers post or my day 13 through 25 post? I still haven't decided what I'm gonna do. Um, I have a few ideas. There are a few things we can do this month. So a nice string. It contains at least 3 vowels. So that's here. Contains at least 1 duplicate, and then no bad strings. So we've got our bad strings listed. So bad strings dot for all. Let's say not bad strings that exists. There should be no bad string that contains no such that s dot contains that bad string. And then so we just add all those together. There does not exist a bad string such that our string contains it. Oh, you saw both posts. Yeah, Cinecore. I'm curious too. Um, Eric Wassel told me about it like a couple of years ago on a day 25. I was like, what do I do next? And he says you should do Cinecore. So I've been meaning to do that for a couple of years now. But I think we should get the word out. We should get everyone to do Cinecore on day 13 this year. I think it's nice when everyone's doing the same thing on the same day, you know? So maybe that. Okay, so we have our nice function. How many strings are nice? So we just do input.count nice. 69 of them. Wait, there's an issue here. Missing parameter type. You need a parameter. You cannot infer the type of parameter s. We'll call it b. It's a pair. I think we might be shadowing a variable there. Oh wait. Contains is not right. Exists. Exists a p such that p dot head is equal to p dot last. Okay. That ran in 1 second, but it's not showing me my output. 0? There are 0 nice strings. That doesn't seem right. Let's check. Nice A. That should be nice, right? Okay. This one should be nice. Right, it has three vowels, a double letter, and none of the disallowed substrings. Okay, let's see if we. So why does this give us 0? Uh, what does our input look like? Oh, this is from the wrong day, that's why. Day 5. 236. All right, I feel a little bit more redeemed. Part 2. Santa has switched to a better model of determining whether a string is naughty or nice. None of the old rules apply, as they are all clearly ridiculous. Now, a string is one with all of the following properties. Um, okay, so we have a new nice function, def nice 2. Yeah, exactly, the camaraderie of ASC. That's what makes it really fun, is the fact that there are so many people in the world doing it at the same time. I mean, by the end, there's like 200,000 plus solutions to day 1. Yeah, and appreciating Eric, totally. We should do it. Okay, it contains a pair of two letters that appear at least twice in the string without overlapping, like XY, XY. Okay, let's just make our functions so we can test those conditions separately. So def um, pair appears twice in a string. 8,600 day ones? Yeah, not 10,000 yet. Hey, Q Ultimus is here. How did we do? Jeez. I tanked for a bit, but I got there. I'm gonna put up my code. I need to go to the bathroom real quick. Um, but here's my code for day 1. It should be pretty readable. Be right back. Judging by the old leaderboards, your own participation is lower this year. Or maybe everyone just forgot. Yeah, I don't know. Maybe it's just slow. Maybe people are less excited because it's only 12. You'd think you'd want to milk it for all it's worth if there's only 12, right? You forgot that the dial could loop multiple times. Yes, I did that too. Um, and there's a point when I was reasoning, I was saying, okay, it only goes to 99, right? So I scrolled up and down and I looked at the problem. I was like, okay, none of these are more than 99. And I went with it. And then later when I'm trying to debug that, I see the warning. It's even explicitly stated. Uh, yeah, reading comprehension. I even considered it. I was like, there might be, and I decided that it wouldn't be for some reason. You fix up your code for multiple rotations when you saw it in a description. It broke the special case when I did that. You know what? Hold up. Chats are not showing up on screen for some reason. Let me just double check that real quick. I'm just gonna restart that. Yep, classic AOC moment. Let's just get out of the way now, huh? Broke your special case when you did that. Okay, let's do this day 5 from 2015. So a pair appears twice. Um, doesn't overlap. So we could do like an index where. So, well, actually, no. We should get, I guess, all of the pairs. We could do s dot sliding. What happens when you do sliding on a string real quick? Stewart dot sliding two. Uh, for each print line. That should print strings, right? Yeah. So what I could do is zip that with index. Sliding two dot zip with index. Um, and I guess we could do like a count of each of these. So a count. Um, this is gnarly, but this is kind of my idiom for doing a count. This gives us a map. I'll give a typeset. It's understandable. Um, so this is a map from each tuple of the string with its index, like pair string, to a, I suppose this would be, I'm not sure what the type of this is actually. I mean, it's some sort of seek. Group map reduce is not a member of iterator string. Okay, that's why it's hard to figure out what type it is. Let's do to list. So this will be like a list of all of those. So string and int. It contains a pair of any two letters that appear at least twice. So counts.exists. And here's the pair, and there's the index. Oh, hold on. No, we're going to group, we can't group by identity. So we're going to group by on this pair. So we have like the pair index. We're going to group by the pair itself. And I suppose we don't need to do the whole count. We're gonna leave this as a group by. I'll make it easier to understand too. So a map from string to a list of the string paired with the index. Okay, so pair and then positions, appearances. Actually, I think we just want all the indices in which it appears. So I'm going to change this group by into group map. And we'll just get the second bit of this. So this just becomes a list of indices. So this is, yeah, appearances. So here's some indices. The music is stuttering. Oh, it's not the whole stream that's stuttering, is it? Oh, is it like the audio is stuttering because of my noise cancellation? That could be it. Here, how's it sound now? Yeah, let me know. Keep an eye on that. Hey, Just Barrett, welcome. So we have our appearances, we have all these indices. So you want a case where that exists, indices that size is greater than or equal to 2. And what else? Those indices have to be separate. So either let's just do the equal case. So it's either indices the size is 3 or greater than 2, or so my thought here is that if there are only 2, we just want to make sure that they're not next to each other. Or indices that size is 2 and the difference. So indices dot head minus indices dot last, absolute value of that is not equal to 1. All right, it's a little bit clunky, but that should work. So let's test it out. Pair appears twice. It should be false in this. That should be true in this. should be true in this. Okay, false, true, true. Great. So that looks good. Oh, hey, thanks for the follow. Oh, thanks for all the follows. Who joined? Daydream Glitch, Zuno, and Vuthon. Oh, Zuno followed a while ago. I missed that. Okay. Now we have this other condition. It contains at least one letter which repeats itself. Um, wait, which repeats with exactly one letter between them, like X, Y, X, E, F, E, or even A, A, A. Okay, that one's a little bit easier to do. Let's call that def repeat with gap. Okay, so let's just do a sliding as that sliding window of 3 that exists. Um, and there's some strings such that s dot head equals s dot last, right? And let's make sure that's going to work even if you do a sliding window of 3 with just 2 characters. Ooh, that's not nice. Because it gives us a 2. So we have to make sure that the the string that gives us that window is also length 3. Um, yeah, if this is too short, it'll do that. Actually, I don't really need to check that because we're not going to get strings that short that don't also fail the other one. So we're fine with that. So def ands 2, or just val here, val ands 2 equals input dot count strings such that pair appears twice for that string and repeat with gap for that string. Audio stream is lagging. Wait, just the music. Okay, let's turn off the music. We can figure that out another night. By the way, if you ever want to listen to the stream without music, the YouTube version doesn't have music. Wait, 5 is my answer? 51. 51 doesn't seem right. Oh, yeah, 51 was it. Cool. Okay, that's more how day 1 today should have gone. I feel like I've redeemed myself a little bit. The code could be more concise. But hey, we still did 5 problems from 2015. In addition to tonight's problems, I think we'll be able to finish 2015 before we finish 2025. Good. Sorry about that static. I should have been more on top of that. Um, yeah, this has felt like a good little run. Has anyone else been streaming Advent the Code? It does seem like it's been quieter, yeah? I can't imagine other people are still up doing it. Oh, Voyland was doing it. And Templar Alice. I'm not familiar with these people. Oh no, yeah, Voyland I saw on Reddit today. One of the streamers. a Godot developer. So are they using GD script? Yeah, I imagine most people already went to bed, just given it is day one. Oh, Boylan's got a baby. Okay, let's say hi. Let's raid Boylan. Still working on some bugs, probably the same bug we ran into. So let's give them some sympathy. Oh yeah, Michael PC Gamer. Haven't seen them in a while. So raid Voy Lin. All right. Yeah. See you tomorrow. Thanks for stopping by. Looking forward to the rest of this year. Oh, wait. My YouTube stream is still running, so I'm gonna turn this off. Bye if you're on YouTube. See you tomorrow.